Fungi, the hidden heroes of life on Earth. Mycology is the study of fungi, and it is a branch of biology. Fungi may not seem like the most exciting subject for a video, yet they are some of the most amazing and vital organisms on the planet, and have been for the whole of the Earth's existence, maybe up to 1 billion years. Fungi, which are distinct from both plants and animals, constitute their own kingdom, with millions of species in various shapes and sizes. A snake and a giraffe, or a chicken and a dung beetle, for example, can be as dissimilar as fungi. Although we often associate fungi with mushrooms, this is merely the fruiting body of the fungus. There is much more going on beneath the surface. Some fungi are tiny and cannot be seen with the naked eye. While one fungus, the humongous fungus, is thought to be the world's largest organism by area, encompassing 2,200 acres in Oregon, the United States. The name fungus may conjure up bad associations in some people's minds, and some fungi can cause infections or diseases, while others are dangerous, and that hairy stuff growing on your strawberries is also a fungus. While the negative aspects of fungi are often clear, they are also a powerful force for good. We simply aren't aware of it. Fungi aren't something we think about very often, but they are, and have always been, vital to the planet's environment. Indeed, to argue that life as we know it would be impossible without fungus is an understatement. We'll have to travel back a few years to see how. Several billion years, to be precise. The oceans have long supported life in the form of tiny single-celled organisms, but the land, as far as we know, was mostly rocky and lifeless. When some of the first bacteria achieved the ability to photosynthesize, the process of turning sunlight into nutrients, things started to change. More oxygen in the atmosphere led to an acceleration of more complex species in what is known as the Cambrian explosion, which occurred around 540 million years ago, but this was virtually restricted to the ocean. Fungi, with their unique capacity to consume rocks, break them down, and turn them into soil, made it feasible for more complex living forms to shift to land. This is accomplished through the secretion of digesting enzymes as well as mechanical pressure. Fungi had access to nutrients that would have been unavailable to any other organism at the time. Fungi were supposed to have begun to move onto land some 60 million years after the Cambrian explosion, and they would have profited from access to more than 2 billion years of bacteria on the coast to feed on. Of course, there are many gaps in the fossil record from this time period, so there's a lot of speculation, including the idea that fungi were already on land 500 million years ago. Regardless of how long fungus had been on land before being followed by little proto-plants, primitive organisms that could photosynthesize, we are quite convinced that they were eventually followed by small proto-plants, simple organisms that could photosynthesize. Plants had photosynthesis and fungi had minerals, but they both needed the other to survive. In a process known as symbiosis, fungi and plants began to work together to develop a mutually beneficial connection. Fungi and plants began to colonize the land and render the earth green as they expanded. Many other sorts of plants that had yet to evolve found the soil to be more suited, allowing some to become independent of the fungi. New, dynamic balances were developed as ecosystems became increasingly complex. The increase in oxygen produced by plants was counterbalanced by an increase in the number of species that required oxygen to survive. Similarly, the organic matter that began to accumulate after things died needed to be recycled so that it might be used again. This is when fungus entered the picture. Simply said, fungus consume death, allowing nutrients to be reused by live things by breaking down dead items. Fungi served as one of the final building bricks for the planet we know and love today, establishing yet another vital cycle that is essential to the survival of all species on Earth. Older partnerships continued to thrive as new cycles were being built and matured into what would lead our current ecosystems. The so-called mycorrhiza symbiosis between plants and fungi has continued to adapt and evolve to this day, allowing for increasingly complicated relationships to form. ectomycorrhiza, in which the fungus wraps itself around the plant's roots, and endomycorrhiza, in which the fungus penetrates the plant's cell wall and entangles itself around the cell membrane, are the two forms of mycorrhiza. However, as intrusive as this may appear, it may really make it easier for the plant to benefit. Because the fungus aids the plant in obtaining more nutrients, the plant will happily allow another organism to reside inside it. The great majority of plants today benefit from a symbiotic interaction with a variety of fungus species. According to some estimates, 90% of the world's plants exist. After millions of years of coevolution with fungi, some plants still rely solely on them for existence. During its germination stage, the orchid plant family, for example, has essentially no independent energy store, that is, while it is growing from a seed into, well, a plant. Many orchids now have a symbiotic connection with fungi that isn't favorable to both parties. Many of these species are parasitic on particular fungi, with the plant sucking the energy from the fungus, which is referred to as the host in this scenario. At the same time, the fungus may be in a symbiotic relationship with another plant, allowing the orchid to acquire its energy indirectly through photosynthesis, even though many of these species have lost their capacity to do so. Parasitism can also occur in the opposite direction, with a fungus acting as a parasite on a plant. In addition to facilitating nutrient exchange between fungi and plants, fungi can also assist plants in facilitating nutrient exchange inside themselves. A little tree in a forest with limited sunlight, for example, might be fed extra nutrients to assist it in growing tall enough to photosynthesize on its own. Common mycorrhizal networks are more sophisticated sorts of relationships between a fungus and potentially many distinct plants, ranging from the tiniest blooms to the tallest trees. Fungi have the ability to connect vast forests, a phenomenon known as nature's internet or, more amusingly, the Wood Wide Web. Let us know what you think in the comments. Thank you for watching, and don't forget to like, share, and subscribe. Could be anything channel as always. See you next time.